Is it? I think it is. Well, let's see. Is it going to bounce? All right, we're good to go. But thank you for checking. All right, the solid lies between planes perpendicular to the x-axis, and x equals 1, x equals negative 1, x equals 1. The cross-section is perpendicular to the x-axis are circular discs whose diameters run from the parabola y equals x squared to the parabola y equals 2 minus x squared. So this looks like a football. If you cut a football and you look at the image, you're seeing a circle. Well, what we're doing here is we're taking the area, which is a circle, pi r squared, and we're adding up an infinite amount of circles. Now, if we could do that, and we do that with integration, when we do that, you get volume. So when you take a two-dimensional object, you add up an infinite amount of those, you get a three-dimensional object. Pretty confident that we have symmetry here over the y-axis. So we're going to double the integral from 0 to, I need that intersection point. Or in fact, I can get both of those intersection points by setting x squared equal to 2 minus x squared because they both equal y. So we add the x squared over, we get 2x squared equals 2. X squared equals 1. So x is plus or minus 1. Now I know that I'm integrating from negative 1 to 1. That's where they intersect each other. But if I use symmetry, I'm going to integrate from 0 to 1 because I really like plugging 0 in. I don't like plugging negative 1 in, even though it's not that much harder, but this makes it a little easier problem, I think. The diameters of the circle run from the bottom parabola to the top parabola. So if we take the function value of the top, that goes from the x-axis, to this curve, if we take all of that and minus out that little piece right there, we get that line segment in between the two equations. So that's your r. So we have pi times, r is the top parabola, 2 minus x squared, minus the bottom parabola, minus x squared, but that's the diameter and we want the radius. So we're going to have to divide that by 2, and we are integrating with respect to x. We don't want the diameter, we want the radius, so we got to divide by 2. Well, I can pull constants out, so that pi goes to the outside, 0 to 1. We have 2 minus 2x squared over 2 squared dx. Then I can divide by 2. 0 to 1, we got 1 minus x squared, but that's squared dx. So I've simplified the function a little bit. We have to square. We have 2 pi, 0 to 1. 1 minus 2x squared plus x to the 4th dx. I guess I don't need the parentheses now. Doesn't hurt anybody. We have 2 pi times x minus 2/3 x to the 3rd plus 1/5 x to the 5th. We're integrating from 0 to 1. So there's the integral of the polynomial. And if you're left with a polynomial, I encourage you to use your calculator, unless you think you need some practice integrating this stuff and doing this by hand. That's up to you now, really. That's going to be 1 minus 2/3 plus 1/5. And we do have to plug 0 in, but that gives us 0. There's no cosine of 0. There's no e to the 0. So I'm not worried about anything not being 0. 2 pi, let's see, we got 15/15 minus 10/15 plus 3/15. 2 pi times 15 minus 10 is 5, plus 3 is 8. So we have 8/15, and we end up with 16 pi over 15 for the volume. That's the volume now. Any questions? Now, other things you're going to encounter. Do you have some white space left? Or maybe a little bit of white space left? What if we did, everybody get that? Are we all good? Okay. Good now?
Oh, I wrote it down wrong. Okay.
What if instead of circles, the cross sections are squares with the bases in between the two parabolas? Well, now the area, the cross-sectional area is s squared. The area of a square is just side squared. Now we can integrate from 0 to 1 of s squared but dx with respect to x. So we're going to add up an infinite amount of squares this time, but we want to get the area of a square in terms of x now, not in terms of s. Well, this is the entire side. We don't want to take half of that. We want the whole side. And that's still the top function minus the bottom function. That's 2 minus x squared dx. But we want that to be squared, of course, because it's side squared. That is the side. 0 to 1 of 2 minus 2x squared squared. Integral from 0 to 1 of, oh no, I'm going 0 to 1, but I do have to double this. I forgot. Oh, I almost forgot that. That would have been bad. Now, if I'm going from negative 1 to 1, I don't need that too. But I'm using symmetry. All right, so we have 4 minus 8x squared plus 4x to the 4th dx. 2 times, let's see, 4x minus 8 thirds x to the 3rd plus 4/5 x to the 5th from 0 to 1. Two times 4 minus 8 thirds plus 4/5. We like plugging in 1, and we really like plugging in 0. 60 fifteenths minus 40 fifteenths plus 12 fifteenths. So 2 times 20, 32 fifteenths, 64 fifteenths is what I get. So that's when we have squares and the bases are on the XY plate. One of the sides, I should say. Go ahead.
Just go to the bottom.
Yep. There you go. Yeah. Did that too fast. Good. All right. I'm going to keep this rolling. That's the end of notes. But what I did first hour is I went through I actually did 2 and 3 with everybody. You certainly don't have to watch that. We sang a little Mariah Carey today. Your assignment is, where are we at? We're at 483. I'll write this up on the board here. 1, 3, 5, 6, 39, 41. And what I think I'll do, I'll let you get a head start on this. And I know a couple people want to watch this video. What I'll do is probably make 2 videos. So I'm going to cut this off. I'm going to let everybody get a head start on this. I'll turn this thing back on, and we'll go through 1 and or 2 and 3 or whatever it is. I'll go through 1 and 3 with you if you want to watch.